preparation of haloalkanes. In the previous class, we have discussed about the introduction of haloalkanes and IUPAC nomenclature of haloalkanes and their classifications on the basis of hybridization and bonding. Today we will start with the preparation of haloalkane from alcohol. When alcohol is treated with a chlorinating reagent, that can be PCl3 or PCl5 or thionyl chloride in presence of pyridine or hydrochloric acid in presence of anhydrous zinc chloride or antimony chloride we can take, stannous chloride we can take, or we can take chlorine in presence of red phosphorus, which will give chloroalkane. Here we can use also we can prepare bromoalkane by this method also, but for chlorination PCl3, PCl5 and thionyl chloride are very good chlorinating agent. They are capable to replace OH group with chlorine. This can replace also OH group from carboxylic group to form acid derivatives. In the next preparation, we will discuss about the preparation of haloalkane from saturated hydrocarbons. Saturated means the hydrocarbon which have all similar bond lengths or sp3 hybridized or all are single bonds. Now we will treat halogen with saturated hydrocarbon in presence of sunlight. जदि आम हालोजेन एटी क्लोरीन नबा जितेबाला क्लोरीन को आम मिथेन सहित ट्रीट करवा इन प्रेजेंस ऑफ सनलाइट आम कौन पाइबा क्लोरोमिथेन. एटा गोटे फ्री रैडिकल मेकानिज्म. It is continuous. This reaction will continue until all the hydrogen attached to sp3 carbon are replaced by chlorine. So this will proceed further. Chloromethyl will further react with chlorine in presence of sunlight to give dichloromethane with release of HCl. Again, dichloromethane will react with chlorine in presence of sunlight to give trichloromethane, which is also known as chloroform. Then chloroform will further react with chlorine in presence of sunlight to give carbon tetrachloride. It is tetrahedral in structure and non-polar solvent. The reaction will not continue further because all the hydrogens are replaced by chlorine atom. We will proceed to next preparation, that is preparation of haloalkane from unsaturated hydrocarbon, that is alkene. Unsaturated means carbon containing double bond or triple bond, or we can say simply multiple bond, is called unsaturated hydrocarbon. But here we will discuss about only double bond or sp2 hybridized carbon. So sp2 hybridized or unsaturated hydrocarbon can be of two types, that is symmetrical or unsymmetrical. In case of symmetrical, we will find both the sp2 hybridized carbon contain equal number of hydrogen atom, in which it is difficult to identify which site is the region to attack. But in case of unsymmetrical alkene, we will get different number of hydrogen atoms in sp2 hybridized carbon. Then we can decide the site where to attack. So this is called unsaturated hydrocarbon. So this is the example of sp2 hybridized carbon, sorry, unsymmetrical alkene. And if unsymmetrical alkene is there, then we can use Markovnikov's rule or anti-Markovnikov's rule. Let us understand the Markovnikov's rule. When unsymmetrical alkene when unsymmetrical alkene reacts with halogen acid, halogen will attack to the sp2 hybridized carbon containing less number of hydrogen atom. Here we can see that these are sp2 hybridized carbon, and out of that one sp2 contains one hydrogen atom and another sp2 hybrid contain two hydrogen atoms. So according to the rule, halide ion or halogen atom will attack to the sp2 hybridized carbon containing less number of hydrogen atom. So halogen atom will attack to carbon. This number contains one hydrogen, so it will attack here. So our product becomes 2-chloropropane. Always remember, the side where halogen will attack, just opposite side will be attacked by hydrogen atom. Let us discuss about other rule, that is anti-Markovnikov's rule. It is also known as crash reaction, and it is just opposite to the Markovnikov's rule. If the if unsymmetrical alkene is treated with halogen acid in presence of peroxide, then halogen will attack to the sp2 hybridized carbon containing maximum number of hydrogen atom, and hydrogen will attack just opposite to the sp2 hybridized carbon. So here we can see this carbon atom has two number of hydrogen atom while the another one has one hydrogen atom. So here halogen will attack to the sp2 carbon containing two hydrogen atom. So our product will be 1 halo alkane. Now, in the last class, we discussed that fluorine and iodine, due to size and electronegative value, they have specific characteristics, they are differentiated. So we will discuss about their preparation by the method called halogen exchange reaction. There is two types of halogen exchange reactions. One is called Finkelstein reaction. In Finkelstein reaction, we will exchange iodine with other halogens. So let's see. When haloalkane is treated with sodium iodide or potassium iodide, it will produce iodoalkane. Here, halogen can be chlorine or bromine, and that should be substituted with iodine to give haloalkane. Similarly, another reaction is Schwarz reaction. This reaction is used to prepare fluoroalkane. It is also a halogen exchange. When haloalkane reacts with silver fluoride or mercurous fluoride or cobalt fluoride or antimony trifluoride will give fluoroalkane. Here X can be chlorine or bromine to get fluoroalkane. So these are special reactions for the preparation of normally highly reactive element fluorine and least reactive element iodine.